Hey everyone, welcome back. Today we're diving into protocols. We'll look at what they are, how they work, and why they're so important in our digital world. Whether you're new to this or just looking to refresh your knowledge, I've got you covered. Let's get started. HTTP stands for Hypertext Transfer Protocol. It's the system that allows your browser to talk to web servers, helping you load everything from text to videos. Here's what happens. When you type a URL into your browser, it sends an HTTP request to the server that hosts the website. The server responds with the requested content, and your browser displays it. Every exchange includes a request and a response. For example, a GET request is used to retrieve data, while a POST request is used to send data to the server. You've probably seen status codes like 404 not found or 500 server error. These are part of the response and tell you whether the request was successful or if something went wrong. Now, for security, we use HTTPS. The SI stands for secure. It encrypts the data being transferred so nobody can snoop on your connection. HTTP has also evolved. HTTP 1.1 made connections reusable. HTTP 2 brought in faster performance with multiplexing. And HTTP 3 uses a new protocol to make things even quicker and more reliable. And that's HTTP. FTP stands for File Transfer Protocol. It's one of the oldest methods used to transfer files over a network. Developed in the 1970s, FTP lets a client connect to a server and upload or download files using a set of simple commands. It operates over TCP, usually on port 21. When you connect to an FTP server, you'll usually need a username and password, but some servers allow anonymous access. Once connected, you can list directories, move around, and transfer files. There are two modes, active and passive. In active mode, the server initiates the data connection. In passive mode, the client does. Passive is more firewall friendly, so it's more common today. FTP is plain text, which means usernames, passwords, and data are sent unencrypted. That's a huge security risk. To fix that, we have FTPS and SFTP. FTPS is FTP over SSL, adding encryption. SFTP is a completely different protocol that uses SSH to transfer files securely. Still, plain FTP is used in some internal systems or legacy apps, but for the open internet, it's mostly obsolete. So to recap, FTP is simple and useful, but not secure. Use FTPS or SFTP instead, and that's FTP in 100 seconds. TCP stands for Transmission Control Protocol. It's one of the core protocols of the internet. Whenever you load a website, send an email, or stream a video, chances are TCP is doing the work behind the scenes. TCP runs on top of IP, which handles packet delivery. But IP doesn't guarantee those packets arrive in order or even arrive at all. That's where TCP comes in. Here's how it works. First, TCP sets up a connection using a three-way handshake, SYN, SYN-ACK, ACK. This establishes a reliable connection between the client and server. Then data is broken into segments and sent over the network. Each segment has a sequence number so the receiver can reassemble everything in the right order. TCP also uses acknowledgments. For every chunk of data received, the receiver sends back an ACK. If the sender doesn't get an ACK, it resends the data. It also uses flow control to avoid overwhelming the receiver and congestion control to avoid overwhelming the network. This makes TCP great for applications where accuracy matters, like websites, file downloads, and email. But it's not ideal for real-time stuff like video calls or gaming. That's where UDP comes in. So, to recap, TCP is reliable, connection-based, and ensures your data arrives safe and sound. UDP stands for User Datagram Protocol. It's another core protocol of the internet, just like TCP, but with a very different vibe. Whenever you're in a fast-paced online game, watching a live stream, or on a video call, UDP is probably doing the heavy lifting. Like TCP, UDP runs on top of IP. But here's the key difference. UDP doesn't guarantee delivery, order, or error checking. And that's on purpose. UDP is fast, it's connectionless, and low overhead. There's no handshake, no acknowledgments, no retransmissions. Here's how it works. The sender just fires off packets and called datagrams to the receiver. That's it. No waiting, no checking if they arrived, and no resending if they didn't. Each datagram has just enough information to get to its destination, but UDP doesn't care if it arrives out of order or gets dropped along the way. Why would you want that? Because in real-time applications, speed matters more than perfection. If you're in a video call, you'd rather miss a frame or two than freeze waiting for perfect data. UDP is also great for broadcasting messages to multiple devices at once, like streaming video to many users. So to recap, UDP is fast, lightweight, and connectionless. It trades reliability for real-time performance. SMTP stands for Simple Mail Transfer Protocol. It's the backbone of email delivery across the internet. Whenever you hit send on an email, SMTP is the one making sure it gets to the right inbox. SMTP is a text-based protocol that works over TCP. Why TCP? Because email needs to be reliable. We don't want half an email showing up, or worse, not showing up at all. Here's how it works. First, your email client connects to your outgoing mail server using SMTP. Then SMTP kicks off a conversation, literally. It starts with a handshake using standard commands like HELO or EHLO, followed by authentication. Once connected, it sends the envelope info, who the email is from and who it's going to. Then comes the message itself, subject, body, attachments, everything. SMTP sends this data to the recipient's mail server, which stores it until the user checks their inbox using another protocol like IMAP or POP3. One thing to note, SMTP is only for sending email. It doesn't handle reading or storing messages. SMTP also doesn't encrypt messages by default, so most modern servers use Start TLS to upgrade to a secure connection. DHCP is like your internet's personal assistant. It automatically gives your devices the IP address they need to connect to a network. When you connect to Wi-Fi or plug into a network, your device needs an IP address to communicate. Instead of manually assigning one, DHCP does it automatically. Here's how it works. 1. Your device sends a request saying, hey, I need an IP address. 2. The DHCP server responds with an available IP address from its pool. 3. Your device gets the IP address, subnet mask, and other important network details like the gateway and DNS server. DHCP makes network management super easy. Without it, we'd have to assign IPs manually to each device, which is a nightmare, especially for large networks. It also prevents IP conflicts, making sure no two devices end up with the same address, and that's DHCP. It's quick, efficient, and keeps your devices connected. Thanks for watching. Like, subscribe, and catch you in the next one.